Okay, now we're going to begin with one type of problem, and that's called quotient of powers. Now, quotient means division, and so it's going to involve division in powers. In the table, I've already explained that this a to the power of m over a to the power of n is equal to a to the power of m minus n. So you can just subtract the subtract the bottom number from the top number, and then you'll get your results there. Now, you can jump back and forth to those as resources and put them on vocab cards, but I think it's really helpful if you picture these and imagine how they work out. To make these early ones stand out, I'm going to end up writing them in different colors. So in each of these we're told to simplify, and we have to assume that denominators do not equal 0. So we would not be able to do these if they did equal 0, so it's just kind of keeping it simple, and later on you would solve problems involving these, and you would set the denominator equal to 0, and you would talk about what it cannot be equal to. So for this first one, all I see is that I have a to the power of 5, and you'll have to write this one, times b to the power of 8, all over, that looks so much like a Q, I'm going to try to erase that a little bit. There, that's better, that's an A. A to the power of 5 times b to the power of 8 over a times b to the power of 3. Now, over to the side, I'm going to write this. Well, you have a to the 5th would be a times a times a times a times a, and if that were over just one a, then I would cancel these out and be left with just 4 up top. So I feel pretty comfortable doing this. I'm going to put a 1 there if you want, but cross this out, cross the 5 out, and change it to a 4. For b to the 8 over b to the 3rd power, I felt comfortable with my understanding of these because I had b in the numerator 8 times. Let me check my count, make sure I didn't mess up. 1, 2, 3, 4, 5, 6, 7, and then 8. Sorry about the handwriting there. And then 3 times. So there are 5 more appearances of b up top than down below. Okay, that just makes sense to me that I could move on to the problem, crossing out b cubed. Now, I'm not going to just cross out this 3. I want to cross out the whole thing because that way it's going to discourage that I rewrite b in the denominator for this problem. Now, just like we did in the earlier one, scan left to right. I see in my numerator that I have a to the 4th. And see in my numerator I also have b to the 5th. I scan through my denominator, and all of those didn't disappear becoming 0. They really turned into 1 down here. So I will box a to the 4th, b to the 5th as my final answer. Let's check out another example. Now this problem says x cubed y to the 4th, and when I'm saying this problem says, I'm looking at a sheet for these problems. That's why I'm talking that way if it sounds weird. And then x squared y. So I have x cubed y to the 4th over x squared y. Now if I just use the rule, I'd do 3 minus 2 for the x's. Well, there's more up here than there are down below, so I'll cross out all of that. I can put a 1 if I want, or I can just leave it. I think for this one it's probably helpful to have that x. And if you want, in the same step, you could rewrite that x. There's 4 y's up top, and if you need to see it, there's 1 down here. I will cross out my y down here because I'm left with 3 more up top. And if I purely use the rule, so if I look at just the rule, this is 4, this is 1, and 4 minus 1 is 3. But I prefer to think of it as being, there's 4 a's up top, 3 underneath. There's 4 up top, 1 underneath. That leaves me with 3 in my numerator. So I have x times y cubed. I box it. That solution is done. Now these ones aren't so intense that you can't just redo them in your head kind of quickly. So you might be like, well, here's 3, there's 2. Okay, that checks out. There's the one I had. And then there's 3 up top. because that came from 4 minus 1. And I'm kind of just talking to myself like to show, and I'm modeling how you might think of those. So that's dealing with quotient of powers. So let's move on to the power of a quotient. And hopefully each of these, as we add on a new layer, makes decent sense and you feel good with it. So a reminder here, if I have a fraction being raised to some power, then that becomes a to the m over b to the m. I can just attach that exponent to both of them. And that's where I explained that, if you had 1/2 times 1/2 times 1/2, that's the same as 1 cubed over 2 cubed. So that makes clear sense to me. At the top of these notes, write power of a quotient. Then write simplify and set up this first example. I'm going to move on and you can pause if you need to give yourself time to write that. In my fraction, I have 2p squared over 3 raised to the power of 4. Now this is a little bit more involved. I think I'm going to show something more simple than they give you. So let's do a second example over here before we move on to this one. Okay, let's say I have x squared over y cubed. Well, that means that this exponent of 3 is going to attach to the numerator and the denominator. So I'm going to have x squared times x squared times x squared. But you'll also remember from the multiplying notes that that just becomes x to the power 6. And then the y gets the 3 attached to it, so it's y cubed. Now don't get excited, you can't cancel things out because in order to cancel out variables with exponents, the bases have to match. So that's the only way we can combine these, is if the variables and the bases match. So this says 2p squared. Now let's look back at this more challenging one. The 4 is going to attach to the constant out front, the coefficient. The 4 is going to attach to the 2, but also it will attach to the 3. So I'm going to write this, and I'm not going to evaluate 2 to the 4th yet. I want to show 2 to the 4th. And then I have p. Well, that's really p squared to the power 4, and so I'll do 2 times 4 to get 8, all over 3 to the 4th. When I go and I evaluate the 2 to the 4th, I think, well, that's the same as 2 squared squared, and maybe that makes me do 4 times 4, which gets me more quickly to 16 than if I did 2 times 2 is 4 times 2 is 8 times 2 is 16. And the only reason I point that out is because the denominator has a larger value. I can't do anything with this p to the 8th, so I'll just rewrite that entire thing. But instead of 3 to the 4th, instead of 2 to the 4th, and I'm now picturing 3 to the 4th as 3 squared times 3 squared. Well, this is 9, that's 9, and 9 times 9 gives me 81. Now this seems like it should simplify because it's such large numbers, but I can only divide 16 by 1, 2, 4, 8, 16, and I can't divide 81 by any of those. So this will be a simplified answer. Now there might be a chance that I make a mistake in these videos and you catch me on something. You can type it into Wolfram Alpha and see if I was the one who tripped something up. Okay, let's do 2 more examples. So I'm going to write an example on the left and right. And the first one on the left, as we work in columns, is 3x to the power of 4 over 4, all raised to the power of 3. The other one is going to be 5x to the power of 5 times y over 6 raised to the power of 2. The instructions have not changed. We're still simplifying these, so let's focus on the one on the left and pause if you need to catch up with writing. The 3 out front gets the exponent of 3 attached to it. X to the 4th is now x to the 4th 3 times, so I'll write x to the power of 12. And then in my denominator, I have 4 raised to the power of 3. Well, 3 cubed is 3 times 3 is 9 times 3 is 27. X to the power of 12, there's no combining there. And then 4 times 4 is 16 times 4 is 64. I know that 27 can be divided by 1, 3, 9, and 27, but I don't think that 64 can be divided by any of those. So So I'm going to box this, but like I said, if I make a mistake, you can put what you know it should be on there. Make this an OYO problem, and I'll put the answer up in 5 seconds. In my first step, I put the 2 on everything else, 5 squared, x to the power of 10, y squared, all over 6 squared. And the temptation is to see 25 and want to divide it by 5, and 36 and want to divide it by 6, but that's not simplifying a fraction. 25 over 36 only has factors of 1, 5, and 25 that fit into this number. So 36 doesn't work with those, so we're done. Also, when we're being thorough with these, like I said earlier, you can kind of just redo the whole problem and look at your work. I think it doesn't take too much time as you're learning this as a new concept. And the other thing, too, is you're scanning left to right and making sure that nothing else can be combined. And I see an x, I see a y, but I don't see any other variables showing up in there. So we're done. I think we'll stop this video before we move on to the next type of problem and start a final video that should cover everything else.